All right, if you watched the last video, okay, you saw that I was able to make what's called standing waves. And when I swung the spring, it was really easy for me to get it to swing in this configuration. All right, it was not moving at the ends, and in the middle, it was moving a whole lot. And we said those ends are called nodes. So I can put a little N there. In the middle is called an antinode, where there's a big amplitude. So put like an A there for that one. And this was called the first harmonic. All right, and then I sped up my frequency some, and eventually I landed on this pattern, which just added a node in the middle. So I had a node here, and a node here, and a node here, and that was called the second harmonic. All right, and that's going to give us our definition of standing waves. We're going to say that they're a stable pattern of nodes and antinodes formed by the interference of two identical waves that are traveling in opposite directions. Okay, so the stable pattern of nodes and antinodes formed by the interference of two identical waves traveling in opposite directions. So what happened was I was sending energy out this way into the spring, okay, and then that wave energy was reflecting off of here, and the wave and its reflection were interfering with each other, causing my nodes and antinodes. And we'll put some definitions down here. A node is a position of destructive interference So that's why it has no amplitude there, because the waves are canceling each other out. And an antinode is a position of constructive interference. So down here we have this, and this is what's called close both ends. The ends can't move. Which is what we had in the example. And you have a node at each end. And this is for stringed instruments. Okay, there's a lot of connections to music with this. So we got a node at that end and a node at that end and an antinode in the middle. Now this is called the fundamental or the first harmonic. And for that one, we need to notice that the wavelength of this, if I call the length of this string L, the wavelength is going to be 2 times L. Because a wavelength is like a sine wave. So right here is a full wavelength. This is only half of the wavelength. I'd have to go all the way out here to twice L to get the full wavelength. And we're going to say the frequency of this one, we're just going to call frequency 1, the frequency of the first harmonic or the fundamental. Now, I vibrated a little bit faster, and I ended up with another node. So now I had 3 nodes. All right, and the wavelength of this one, now it's just equal to the length. It's half as big as that one. So I'm going to say it's wavelength 1 divided by 2. And the frequency of this one, it's higher frequency than the first one. It's double. It's going up and down twice as fast. So it's equal to twice F1. To get to the third harmonic, I add another node. So now I have 4 nodes and 3 antinodes. I'm not going to bother labeling those. And the wavelength of the third is just 1/3 of the wavelength of the first. And the frequency of the third is 3 times the frequency of the first. So it's a really simple pattern. If I determined that the wavelength of this was 12, the wavelength of this one would be 6, half as big. Wavelength of this would be 4, 1/3 as big. And if I knew the frequency of this one was 100, The frequency of this one's 200, frequency of that one's 300. Now, wavelength 4 is equal to 1/4 wavelength 1, and frequency of 4 is 4 frequency of 1, and wavelength 5 is 1/5 of wavelength 1, and frequency 5 is 5f1. And every time we're just adding a node to our diagram. All right, now that's what's called close both ends. The ends can't move. In open both ends move. And an example of this is going to be brass instruments. So these usually diagrammed as a tube. Okay, and it's going to move at both ends, so you get antinodes at each end, and you have to have at least one node. So I'm going to put a node here in the middle, and then I'm going to draw the wave that goes from the crest here to the trough there, and then it's going to vibrate. It vibrates a lot at the end, no vibration in the middle. And if I look at this, if I think back to what we know about wavelength, the crest to crest difference is 1 wavelength. So from here to here, I'm only going to half wavelength again. So the wavelength of the first one is going to be twice L. I'm going to have to go all the way over here to get a full wavelength in. And we're going to say the frequency is equal to F1. Now, just like in the close both ends, to get to the next harmonic, I just add a node. So instead of one node, I'm going to have 2. And this is going to look like this. That. And like so. And now here, the wavelength was way over here at 2L. Now the wavelength is just the length of the thing. So wavelength 2 is half wavelength 1, and frequency 2 is equal to twice frequency 1. The same thing that we saw up here. And then for the third harmonic, and let's label that. This is the first, second, and third harmonics. I'm going to add one more node. So I'm going to have 3 nodes. And it's going to look like this. All right. And then lambda 3 is going to be 1/3 the wavelength 1. And frequency 3 is going to be 3 frequency 1. So it's the exact same patterns we saw up here with closed both ends.